me about a time you changed your opinion after hearing others. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand whether you are open to feedback, whether you can change your mind when new information appears, whether you listen to teammates, QA, product owners, and stakeholders, whether you make decisions based on evidence instead of ego, how you handle technical discussions professionally. Better idea, even if it was not originally yours. Quote, whether you value collaboration over being right. This question is especially important for Java developers, backend developers, Spring Boot developers, full-stack developers, junior software developers, senior software developers, team leads, Agile teams. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you listened, evaluated new information, changed your opinion, and helped move the team forward. Question. Tell me about a time you changed your opinion after hearing others. Example 1. Changing opinion about returning all records versus pagination situation. In one project, we were designing a customer search API using Spring Boot. At first, I thought returning all matching records would be acceptable for the first release because the front-end team wanted a simple response structure. Task. I needed to participate in the API design discussion and help choose a solution that worked for both front-end and back-end. Action. During the design review, another developer raised a concern about production data volume. They explained that returning all records could create problems as the table grew. Their concerns included CAPS, large response payloads, slow API response time, CAPS browser performance issues, CAPS database load, CAPS timeout risk, memory pressure, poor scalability. QA also mentioned that testing large result sets would become harder without clear pagination rules. After hearing their points, I reconsidered my original opinion. I realized that my first view focused too much on short-term simplicity and not enough on long-term production behavior. I changed my recommendation and supported pagination from the first version. We agreed on default page size, maximum page size, page number, total records, total pages, result list, sample response JSON. I helped update the API documentation and test scenarios. Result. The final API design was more scalable. Front-end still had a clear contract because the pagination structure was documented early. The discussion helped us avoid a future performance issue. Why this answer works. This answer is strong because it shows check. Willingness to change opinion. Check. Scalability awareness. Check. Listening to other developers. Check. QA consideration. Check. API design maturity. No ego. Example 2. Changing opinion about synchronous REST versus Kafka situation. In one microservices project, our service needed to notify another service when customer profile data changed. Initially, I thought a synchronous REST API call would be better because it was simpler to trace and easier to implement. Task. I needed to help the team choose the right communication pattern. Action. During the design discussion, another developer suggested using Kafka. At first, I was concerned that Kafka would add extra complexity. The Kafka approach required event schema, idempotency, retry handling, dead letter queue, monitoring, consumer testing, eventual consistency. However, after hearing the team's reasoning, I understood the bigger picture. The downstream update was not required before responding to the user. The team explained that a synchronous REST call could create slower user response, direct dependency on downstream availability, timeout failures, Retry complexity. Tighter coupling. Production impact if the downstream service was unavailable. We checked the business requirement with the product owner and confirmed that eventual consistency was acceptable. After that, I changed my opinion and supported the Kafka-based design. I helped define event payload, unique event ID, retry behavior, DLQ handling, consumer test scenarios, monitoring needs. Result: the team implemented the Kafka event approach. The user-facing API stayed fast. The downstream service processed events independently, and the design reduced coupling between services. Why this answer works? This answer is good because it shows: check, openness to technical feedback. Check, REST versus Kafka trade-off understanding. Check, business requirement validation. Check, microservices maturity. Check, team collaboration. Check, practical learning. Example 3. Changing opinion about a QA defect severity situation. In one sprint, QA raised a defect as high severity because an API error message was confusing to users. At first, I thought the issue was minor because the API was technically returning the correct status code and rejecting invalid input correctly. Task: I needed to review the defect and decide whether it should block the release. Action: I listened to QA's explanation. They explained that the error message might be confusing for users and support teams. The message did not clearly say what the user needed to correct. QA also showed that the scenario could happen in a common user flow. After hearing that, I realized I had been looking at the issue mostly from a technical correctness perspective. QA was looking at it from the user experience and support perspective. I changed my opinion and agreed that the defect should be fixed before release. I updated the API response to include clearer validation message, clear level error detail, consistent error code, user-friendly message, correlation ID for troubleshooting. I also added a regression test for that validation scenario. Result: the release went out with a clearer error response. QA and support had better information. The experience reminded me that technically correct behavior is not always enough if the user experience is poor. Why this answer works? This answer is strong because it shows respect for QA perspective, user impact thinking, willingness to reconsider, quality ownership, better error handling, collaboration. Example 4. Changing opinion about a custom solution versus library situation. In one project, we needed to generate PDF reports. Initially, I preferred building a custom PDF generation utility because I thought it would give us more control over formatting and behavior. Task: I needed to participate in the technical decision and help choose the best implementation approach. During the design discussion, another developer suggested using a mature PDF library with a wrapper. At first, I was concerned about adding another dependency, but they explained the risks of a custom implementation. A custom solution would require more development time, more testing effort, handling formatting edge cases, maintaining PDF layout logic, fixing rendering bugs ourselves, more long-term support. Using a mature library would provide text-tested functionality, faster delivery, documentation, formatting support, community examples, less custom code. They also suggested using a wrapper so our business logic would not be tightly coupled to the library. After reviewing those points, I changed my opinion. I agreed that a library with a clean wrapper was a better balance of speed and maintainability. I helped build a small proof of concept and added tests around the wrapper. Result: the team delivered the PDF feature faster. The implementation stayed maintainable because the library was isolated behind our own service interface. The decision reduced delivery risk and avoided unnecessary custom code. Why this answer works? This answer is good because it shows openness to better design, build versus library judgment, maintainability awareness, dependency risk mitigation, proof of concept thinking, teamwork. Example 5. Changing opinion about refactoring during a sprint situation. In one sprint, We were working on a feature in a service class that already had a lot of duplicated logic. Initially, I wanted to refactor the whole service class while adding the new feature. I thought it would be better to clean everything at once. Task. I needed to deliver the feature while improving maintainability without creating unnecessary sprint risk. Action. During code review, a senior developer suggested that a full refactor would be too risky for the sprint. They explained that the service class affected multiple flows, and changing too much at once could increase regression risk. Their concerns included plus large pull request size, plus harder review, plus more regression testing, plus risk to unrelated flows, plus longer QA cycle, plus harder rollback if something failed. After hearing the feedback, I realized my goal was valid, but my approach was too large for the current sprint. I changed my opinion and agreed to a smaller incremental refactor. We decided to refactor only the code touched by the feature. Add tests first. Keep behavior unchanged. Move unrelated cleanup to separate stories. Document the future refactoring plan. Result. The feature was delivered safely. The code improved in the area we touched. The team avoided unnecessary regression risk, and we created follow-up tasks for future cleanup. Why this answer works. This answer is strong because it shows CUC, ability to accept senior feedback, CUC, avoiding over-engineering, CUC, incremental refactoring, CUC, delivery judgment, CUC, code review maturity, CUC, balancing quality and risk. Example 6. Changing opinion about caching strategy situation. In one application, we had a read-heavy API that returned reference data used by multiple screens. Initially, I thought adding caching quickly would be a simple way to improve performance. Task. I needed to help design the caching approach. Action. During the discussion, another developer asked important questions that I had not fully considered. They asked, how long should data stay cached? What should trigger cache invalidation? Can users tolerate stale data? Should cache be global or user-specific? What happens if refresh fails? How do we monitor cache hits and misses? How do we test cache expiry? Should sensitive data ever be cached? After hearing those questions, I realized that adding caching without clear rules could create data correctness problems. I changed my opinion. Instead of adding quick caching immediately, I supported a defined caching strategy. The final approach included cache only reference data. Use a clear TTL. Avoid caching sensitive user-specific data. Log cache hits and misses. Add tests for cache expiry. Define fallback behavior. Document stale data expectations. Monitor cache behavior after release. Result. The API performance improved without creating stale data confusion. The team had a clearer caching pattern for future APIs. I learned that performance improvements still need correctness and operational planning. Why this answer works. This answer is good because it shows capital openness to design questions, caching maturity, data correctness thinking, production awareness, better technical judgment. Example 7. Changing opinion about deployment timing situation. In one release, a backend change was ready late in the day. Initially, I thought we should deploy immediately because the code had passed QA and the release had already been delayed once. Task. I needed to support the release decision while considering production safety. Action. During release discussion, QA and DevOps raised concerns about deploying late in the day. They explained QA availability would be limited after hours, support coverage would be lower, rollback coordination would be harder, monitoring attention would be reduced. The change touched shared validation logic. Multiple APIs could be affected. After hearing those concerns, I changed my opinion. I realized that code readiness was not the only factor. Operational readiness was also important. I supported moving the deployment to the next morning. We used the extra time to prepare. Smoke test checklist, rollback plan, affected API list, monitoring checks, support communication, QA validation scenarios. Result. The next morning, deployment went smoothly. QA, DevOps, developers, and support were available to validate and monitor the release. The experience helped me think more broadly about release readiness. Why this answer works. This answer is strong because it shows: check, openness to QA and DevOps input, production safety awareness, operational maturity, release judgment, team alignment, no ego. Example 8, changing opinion about product scope situation. In one sprint, the product owner asked to include additional functionality in a report feature after development had already started. Initially, I thought we should push back completely because the new request affected backend logic, front-end changes, and QA testing. Task: I needed to help the team decide how to handle the scope change without risking the sprint goal. Action: during discussion, the product owner explained why the new functionality was important for business users. They showed that one small part of the request would provide immediate value, while the rest could wait. After hearing the business context, I changed my opinion. Instead of rejecting the full request, I suggested splitting it. We agreed to include the highest value part now and move the rest to a follow-up story. The final plan included: keep the original sprint goal, keep the small high-value change, update acceptance criteria, define QA scenarios, create a follow-up story, avoid rushing the larger scope. Result: the team delivered the original feature and the most valuable part of the new request. The product owner felt heard. The team avoided overloading the sprint while still supporting the business need. Why this answer works. This answer is good because it shows: copy, business empathy, copy, flexibility, scope management, willingness to change position, agile collaboration, balanced decision-making. Best short answer version. If you need a short interview answer, you can say: in one microservices project, our service needed to notify another service when customer profile data changed. Initially, I thought a synchronous REST API call was the better option because it was simpler to implement and easier to trace. During the design discussion, another developer suggested using Kafka. At first, I was concerned that Kafka would add complexity around event schema, idempotency, retries, monitoring, and dead letter queues. But after hearing the team's reasoning, I realized the downstream update was not required before responding to the user. A synchronous call would make our user-facing API slower and dependent on downstream service availability. We confirmed with the product owner that eventual consistency was acceptable, so I changed my opinion and supported the Kafka-based design. As a result, the user-facing API stayed fast, the downstream service processed updates independently, and the design reduced coupling between services. It was a good reminder that the best decision is not always the simplest one initially, but the one that fits the business and system requirements. Common mistakes to avoid. 1. Saying you never change your mind. Bad answer. I usually stick with my opinion because I trust my judgment. Better answer. I use my judgment, but I am willing to change my view when others bring better evidence or context. 2. Making it sound like you were wrong about everything. Bad answer. My idea was bad, and the other person was right. Better answer. My original idea had some advantages, but after hearing the trade-offs, I realized another option fit the situation better. 3. Changing opinion without reason. Bad answer. I changed my mind because others disagreed. Better answer. I changed my opinion after reviewing new information, risks, and business impact. 4. Ignoring your contribution after changing. Bad answer. I agreed with them and stopped contributing. Better answer. After changing my opinion, I helped improve and deliver the final solution. 5. Showing ego or defensiveness. Bad answer. I did not like their idea at first, but I finally gave in. Better answer. I listened to their reasoning, compared the trade-offs, and supported the better approach. Best practices for answering this question. Use the STAR method. Start with your original opinion. Explain why your original view made sense. Show what others said. Explain what new information changed your mind. Avoid ego. Support the new direction actively. Show a positive outcome. Emphasize learning and collaboration. Make it clear you changed because of evidence, not pressure. What interviewers are looking for. Interviewers want to see whether you can listen to others, accept better ideas, change your mind professionally, value evidence over ego, collaborate in technical discussions, consider business and user impact, support team decisions, continue contributing after changing direction. For senior roles, they also want to see intellectual humility, technical maturity, decision-making flexibility, influence and openness, trade-off analysis, stakeholder awareness, leadership without ego. Strong words to use in your answer. You can use words like check, reconsidered, check, listened, check, evaluated, check, compared trade-offs, check, acknowledged, changed my opinion, check, supported the better approach, check, aligned with the team, check, adapted, check, learned, check, contributed. Example: after hearing the team's concerns and reviewing the trade-offs, I reconsidered my original approach, changed my opinion, and supported the solution that better matched the business requirement and production needs. Good change of opinion topics you can use. Depending on your experience, you can talk about REST API call versus Kafka event, returning all records versus pagination, QA defect severity, custom solution versus mature library, full refactor versus incremental refactor, quick caching versus defined cache strategy, late day deployment versus next morning deployment, rejecting scope change versus splitting scope, synchronous versus asynchronous processing, skipping documentation versus lightweight documentation, large pull request versus smaller PRs, database query design, feature flag versus direct release, technical debt priority, test coverage for shared code. Final summary. Tell me about a time you changed your opinion after hearing others is an important interview question because strong developers are confident but also open-minded. The best answer should include: what your original opinion was, why your original opinion made sense, what others explained, what new information changed your view, how you responded professionally, how you supported the final decision, what result improved, what you learned. Good examples include changing from REST to Kafka, changing from returning all records to pagination, changing view on QA defect severity, changing from custom solution to library, changing from full refactor to incremental refactor, changing caching approach, changing deployment timing, changing scope position. The strongest answers show listening, humility, evidence-based thinking, collaboration, adaptability, and commitment to the best team outcome.